Hello, everybody. I would like to end our conversation about the formation of stars by actually taking a look at some observations of stars forming. So, looking at protostars and, more interestingly, their effects on the surrounding molecular cloud around them. So, there will be a little bit of new material. It's not going to just be pretty pictures of forming stars. We're actually going to look at some of the environmental interactions that a forming protostar has on the larger molecular cloud that is being birthed out of. So let's go ahead and have a look and talk about the observations of star formation. And I want to go ahead and start with just some of the observations of star formation, because we talked about forming these fragments, and then these fragments will collapse in a free fall collapse and a protostar contraction to actually form stars. Do we actually see this occurring out in outer space? If we don't, then that's a pretty bad idea that we have if we can't observationally confirm our theoretical ideas of how stars form. And we see these all over. If you just look at molecular clouds and then you're looking at the proper wavelengths so you can actually see through the dust, then you can see all of these tight, dense knots within the molecular clouds that are either waiting to start star formation, they just need that little kick, or they're in the process of star formation already. And this is just one example. So this is the very appropriately named Snake Nebula. You can see it right there. And this is an infrared light, so we can actually see through some of the dust already. We wouldn't be able to see through this at all in visible light. And we can see that it has these tight little knots of denser material here, 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 all over the place. We can take a look in even longer infrared wavelengths with the Herschel Space Telescope, so the Spitzer Space Telescope, and then we can really see these big dense regions because they're very bright in the infrared where the dust is glowing. So we can see those, and they're marked on this image as P1 and P6. So if we zoom in on both the Herschel images and Spitzer images and some other telescopic images, you can see that in these dense knots, you see all of these fragments, these nebular fragments that will be on their way to star formation. So here you are actually seeing the fragments on their way towards star formation. Those initial stages of star formation, we are observing it. Let's take another look here. Let's go to Orion. So here is the constellation figure Orion. There's Betelgeuse, the shoulder. Here's Rigel near the foot. And here's the sword of Orion hanging off Orion's belt right there. So if you ever look at the middle star of the Sword of Orion, you'll notice that it looks like a fuzzy patch. It doesn't look like a star because it is not a star. It is the Orion Nebula, this giant molecular cloud that's out there that you can see with the naked eye. And yes, Orion is observable now. You have to wait until about 11:30 or midnight here in November for Orion to be up. It's a winter constellation, but if you go out, you can see this naked eye. We can go ahead and zoom in on this and switch from visible light to, say, infrared light. And now we're looking at the one of the molecular clouds in Orion. And then we can go to this dense region within this molecular cloud and zoom in again. This is what it would look like in visible light. And we want to go ahead and highlight these two regions right here. And let's go ahead and take a closer look. So over here, on this top one, if we look in the radio wave so we can see through the dust and peer of what's happening, we are seeing a bunch of these nebular fragments. Here's a scale bar, so we're only at about 0.03 parsecs across. Each one of these is on its way to becoming a star. These are our collapsing fragments. A little bit later in the evolution, once they become protostars, where you can start seeing and defining the visible surface, here you can actually see the different protostars. Really, you're seeing the entire collection of gas and dust that they're forming out of. But yes, you can see the disks that they form and a lot of details. There are plenty of images out there. I encourage you to go ahead and have a look. So yes, we see these stages of star formation out there in outer space. You just have to find a molecular cloud and look. And one of the other topics I'd like to talk about here is, and it's just great for observations because it allows us to sort of go, oh, that's where star formation is happening, is that during these T-Tauri stages, these protostar stages for our low mass stars, If you remember, we talked about that. It's not just the protostar itself. It has a disk of material around it, either a protoplanetary disk, if you want to call it that, or an accretion disk. A- and it will also create out of the poles, so perpendicular to the disk of material, it'll create a jet of materials, bipolar jets of materials shooting away from the system. So materials accreting onto the protostar via the jets, and some of it's getting expelled at extremely high velocities from the poles, creating these bipolar jets. And whenever I say getting expelled at high velocity, I'm talking about hundreds of kilometers per second. Equivalently, I could just say that as hundreds of miles per second. So extremely fast ejection of material through these bipolar jets. So if we take a holistic view at the T-Tauri star, we have the protostar, the disk, and these really, really, really strong bipolar jets that are coming out of the poles. And they're screaming out of the system at very, very high velocity, which you can sometimes observe them themselves. If, say, we look over here with Hubble, we can see this is a object called a Herbig-Haro Object 30. And here you can see the disk of material, and here you can see the jet of material. You can see that they change on timescales of years. You look one year, you look next year, you look the year after that, there are slight differences. So these are very, very, very active regions of outer space. And if we see these jets out there, then we know that we're dealing with star formation. If we see really how these jets, because remember that these protostars are forming in a molecular cloud, so these jets that are leaving are going to go plowing through all the leftover molecular cloud that still might be forming stars. And when we have high speed material that's going to come plowing into the molecular cloud material, you can better bet it's going to create an emission nebula that we can then see. It's going to have a profound effect on the molecular cloud that this star is forming out of. And that brings me to what are called the Herbig-Haro objects, a observational hallmark of star formation. This is where the jets are interacting with the molecular cloud around it. So we have these bipolar protostellar jets, and then they can go out and they can interact with the nebula around them. And one of my favorite ones is if we look right down here. So this is Herbig-Haro Object 1 and 2. We have a protostar, which you can't see in visible light because it's shrouded in dust, but we have the bipolar jets that are coming out of it. And here are where those jets are interacting with the surrounding material. You can see it in full context down here. Again, we are in the Orion Nebula, and these are called Herbig-Haro objects, where we're observing the interaction of these bipolar jets with the surrounding molecular cloud. And if you see one of these Herbig-Haro objects in a molecular cloud, it is a hallmark of star formation. So it's pretty easy to go, a star is forming there. And sometimes it's very apparent that they're caused by bipolar jets. Sometimes you have more intriguing geometries and interactions. This is another one of my favorites. This Herbig-Haro object up here is called the waterfall because it looks like a waterfall. So Herbig-Haro objects, if you're just looking in visible light, and you could go out there and get some pretty decent images of molecular cloud regions with just pretty easy accessible amateur astronomy equipment or telephoto lens and camera and a little bit of patience. You can start seeing these Herbig-Haro objects, and you are finding regions where there's active star formation. Perhaps the best place to see some of this is to go to one of my favorite nebulae out there, the Mystic Mountain in the Carina Nebula. I've shown this several times, but now we can revisit it. I had briefly mentioned this before, but let's go all the way to the peak of Mystic Mountain right here. And here we have this dense clump of the molecular cloud. And what's going on with this sort of jet this way and jet that way? Oh, that is the hallmark of star formation. That is a Herbig-Haro object. This one's the Herbig-Haro Object 901, typically just abbreviated HH901. And that is a dead ringer that, yes, there is a star forming right there. You can see some really, really interesting of the bow shock happening there, where you're actually creating a shock wave. And then here's another one down here. This is Herbig-Haro Object 902. You can see this jet of material that's shooting out of the side right here. And all of these interactions, so we have these bipolar jets, then we have the protostars themselves, which are having extreme protostellar winds that are blowing out into the molecular cloud around it. And then eventually the stars will turn on. And if they become O or B type stars, or even A type stars, or even G type star, or pretty much any star, but really the hotter stars that have ultraviolet radiation, which then can blast through, destroying the molecules around them because UV light has enough energy to break molecular bonds. And slowly over time, the birth of these stars, the protostellar winds, and then the eventual birth of these stars in a flood of ultraviolet radiation will erode away the molecular cloud, leaving the newly born naked stars, where we can then observe them in the star cluster that they were formed. And I just want to go ahead and show you some more images of this. So here we are looking again in the Orion Nebula, and here we're seeing an edge-on protoplanetary disk. So here is another image of a later stage of star formation where we can actually see the protostellar disk, the protoplanetary disk around a forming protostar. This one is edge on. We can see them that are face on as well. There's our protostar in the center, and there's the disk of material around it. And eventually, as these stars evolved along the Hayashi track to become stars, and as they become stars, and they start producing their own energy through nuclear fusion, producing their own light coming out of their photospheres, they'll eventually blow away all the gas and dust surrounding them, leaving these stars as naked stars exposed to the universe where we can easily see them with our telescope. And let's go ahead and end by just taking another look at some more of these Herbig-Haro objects. Here's Herbig-Haro Object 30. You can see the disk of material, and here are the jets going out, and you can see some of the effects of the stellar winds going out as well. Here's Herbig-Haro Object 34 with a very strong jet, and here's Herbig-Haro Object 47. And perhaps one of the most striking ones, taken with the Hubble image, is Herbig-Haro Object 20. And you can see this very just nice, clean jet shooting out of this dense region of molecular cloud where there is a star forming there. All right, so this is going to wrap up our material for star formation. We are next going to look briefly at how stars are going to live on the main sequence, the fundamental changes that are happening in the core, because that will set the stage for why stars eventually leave the main sequence and evolve towards death in what's called post-main sequence evolution. Usually just called stellar evolution. And that is going to be how we will follow a star post-life, post-main sequence life, to its eventual death, either as a white dwarf or a supernova explosion that leaves behind either a neutron star or a black hole. All right, that sets the stage for upcoming videos. I will see you there.